About algebraically finding critical features of a parabola. Okay? Does anyone know what a parabola looks like? Parabola? What? Like that? Okay. Does it have to go like that? Yes. Okay. So we're going to look at that by using the quadratic equation. Any idea what the quadratic equation is? No? Okay, quadratic equation. Y equals ax squared plus bx plus c. Okay, so if I look at this equation and I take out the ax squared, what does that make you think of? Y equals bx plus c.
mx plus c.
Slope-intercept form. Okay? So the bx would be the slope, and then the c is where what? The y-intercept, which is where we start our graph, right? Okay? So the ax squared is our quadratic term. Okay? It shows us which way the parabola will go. Okay. The bx is our linear term. And the c is our constant term. Does anyone know how the A tells me which way my parabola is going to go?
Is it positive or negative?
If it's positive or negative, but what does that tell me? If the A is positive, it opens up. So my parabola will look like this, like that. Okay, so if it's negative, it's going to open down. Huh? Sad face. Okay, so if the A is greater than 1, we're going to have a skinny parabola. So we'll let him know. So if my A is greater than 0 and less than 1, my parabola will be wider. So what does my C tell me?
Your y-intercept.
My y-intercept, okay? So where my parabola goes where?
Next.
To the y-intercept. So if my C is positive, what does that mean about my parabola? What? 0.
Is it going to have 0?
If my C is positive,
It's going to be positive.
Will it intercept positive, at a positive number?
yes, on the y-intercept, okay? So it's going to be up. It'll shift upward, so it's going to be above the x-axis. Okay, so if it's negative, what? So it'll shift down, so it will be below.
What makes it skinny and wide? Why would,
So the bigger your number is, here at your A, the skinnier your parabola will be.
What about like y is half?
It's
Because that's the thing.
Yeah, but like, what is that?
what?
Parabola.
Like in a question form, how would you use this? Like if you were given a word called
okay.
something, how would it be used?
Is it like graph?
Yes, you'll graph it. But there's different things that you could graph it for.
It's like to show
solve for.
increase and decrease. What is it used for?
To show what?
Like, you know how like y equals mx plus b shows like growth and like things getting bigger or smaller, you know?
Right.
So like, what is this?
Hold on, let me know. I know, but increase and decreasing. I'm blank right now.
So like money increase for like companies or something? If they're going
No.
downhill.
Like where you change.
Yeah.
Miss Embry,
There's some things that
it's-
grow exponentially, like that don't grow linearly. So like, if you are looking at, say, a population isn't always gonna grow linearly.
So could it like
It's not gonna be linear. When we talk about exponential, remember when we talked about exponential growth and decay and how it got larger and smaller exponentially? If we had graphed those ordered pairs that we had, so 1 year and $25,000, and 2 years and $13,000, and 3 years and $10,000, you know how when the value of the car dropped and it didn't drop at the same rate?
Yeah.
Okay, so if we had taken those ordered pairs when we did both exponential growth, the growth is going to show the growth, the decay is going to show the decay. And if you had graphed those ordered pairs when we did exponential growth and decay, they would have formed a parabola for you to see, because eventually it's only going to hit, if it's declining, it almost always just goes to a certain, it can't keep declining forever.
Yeah, it's gonna go like that.
It'll either go back up or it'll become extinct. Does that make sense?
Yeah, so could you have like multiple parabolas in a row?
You can.
Are we gonna have one?
No. You only have one parabola.
and that's where, correct me if I'm wrong, the ax squared is because it's that's an exponent, so exponential, so it's like doubling what it is increasing or decreasing.
And the quadratic only works with an exponent of 2. So as long as your exponent is a 2, you're going to have that U shape. If your exponent is a 1, you're going to get that linear shape.
Oh.
If it's anything greater than 2, that's when you're looking at different, they're called piecewise functions, and you won't do those to that algebra 2.
Questions? Seth, are you good on this part? Okay. Okay, so if we look at y equals x squared minus 6x plus 2. Okay, there are different ways that we can solve for these equations and look and find these features. Okay, one way that we can do that is a table. So if we look at a table, what do we do here? Do you know how do we use tables? Input and output. So what do I have to do here?
You put a number in.
I put a number in, okay? So if I put in these numbers in for x, it will give me my output, okay? So once I get my output, what do those two numbers tell me? What would this and this number tell me?
The points on the graph.
It would give me a point on a graph, okay? So then I would come and I would plot that point. So for these numbers, in your calculator, I want you to solve for the outputs, okay? But really quick, before you do that, you can put this whole equation in your calculator, okay? So at x, you need to make sure to, because 3 is negative, you want to make sure to put the parentheses. Can someone tell me where the parentheses are on your calculator?
Above the 8 and 9.
Above the 8 and the 9. So you're going to open a parentheses and put in -3 where x is. And then you want to close the parentheses. Okay, and where's my squared button?
Above the division sign.
Okay, do we have to use the caret if it's just squared? Okay, diagonal to 7, there is a squared button. And all you have to do is hit that. And then you have -6 times x, which is -3, plus 2. So if you enter it into the calculator just like this and push enter, what does it give you?
29.
29. Did anyone get anything different than 29? Okay, make sure that you are using the negative button rather than the subtraction button. And then you should get 29.
Oh my gosh, she's so right above my calculator. So I had done it before me.
Oh.
I just typed it back in.
Okay, and then also, after you do the first one, you can push the blue second button and then the enter button, and that will put the equation back, and you can use the arrows to change the -3 to a -2.
Wait, how do you know which one it is? Just type in the numbers. Do you just use 1, 2, or -1, 2, 3?
You don't always have to use those. It's just depending on what you can pick any numbers that you want to.
The one that changed the point.
But generally, anytime that you're graphing something, you want to pick these numbers. Or I always have.
But like wouldn't it, if you did wouldn't it change the points if you just pick random numbers?
Yes. Yeah.
So how do I know?
Like on this one, you're gonna want to use 0. You want to use. Yes. Yeah. You're gonna plot all of them. And here in a minute, we're gonna talk about it. Is because we'll get to a certain point, but it won't show the whole parabola. So you're gonna have to plot more points. So you're gonna have to put in different numbers to find different outputs. To find out points. Yes. Because you're going to graph it on your paper.
I just put the number in. You only have to put the number on.
Okay, so after you get all of your points, go ahead and draw a 10 by 10 graph. Okay, so if you draw that 10 by 10 graph, what point will you be able to start with? 0, 2. Okay.
I was at tonight, so hot. I'd be sweating.
Okay, so for -3, what did you all say that you got? 29. Can we plot 29?
No.
On a 10 by 10 graph?
No.
Okay, what'd you get for -2?
18.
18. Can we plot that?
No.
-1.
Yes.
Yeah.
Okay, so where am I going to go? -1 where? Up, down, left, 1, and up 9.
Yep.
What about 0?
Yep.
What?
2.
So 0, 2. So I'm going to go to the 0,
Up.
up 2, 1. Nick, what'd you get? When you put in X for 1, or 1 for X, what'd you get for your output? Carlos?
-3.
-3, so I'm going to go 1, -3. Okay, to the right 1, down 3, 2.
-6.
-6. So you go right 2 down -6.
Okay, so right 2, down 6.
-7.
So 3, -7. So I went to the right 3
Yeah.
and down -7. Okay, does that look like a parabola? No. So what could I do to finish the parabola? Add more points.
Oh.
Okay, so what could I add?
More even numbers. Or not even, but more
What?
positive.
Well, I'm almost there. So where?
I'm so confused with
To the bottom, okay? So if it's going to go back up, I'm at 3,
you go 4.
and if I
5.
4 and 5. Okay, so what if I put in 4 and 5?
Wouldn't that make you go back down? Keep on going down.
Keep on going down.
Wouldn't you keep going down?
Put in 4 and find out. Tell me.
Alright.
Well, if you go 1 to 2, you go forward, guys. 1, 2, 3.
Alright, so it would be.
Okay, but you eventually reach a stopping point, right? And it's either going to go up or it's going to be gone.
-6.
Okay, so 4, -6. So what does that mean?
Right 4, down 2.
Okay, so it's going to go back up. Okay, what about 5?
-3.
Okay, and it's going to go up even farther.
Oh, I get it now. I thought it was going like this. That's why I was.
So, repeat that.
Oh.
It reflects, okay? Because this is, it's called a vertex point, and it gives you your axis of symmetry. So this right here makes it symmetric. What does that mean?
Equal to both sides.
The sides are the same. They reflect each other, okay? So the vertex is this point here. What? 3, -7. And that's called my vertex. My vertex on this one is a positive. So my vertex is going to be the lowest point of the parabola. Okay? And then it could also be the highest point, okay? Okay. If it goes down, then it's going to be the highest point of the graph.
Where it bends.
Yes. Okay, questions? Okay, so could someone tell me what the axis of symmetry would equal here? Like what? Y equals 3? x equals 3. Okay? Because this line right here is x equals 3. And that would give me that axis of symmetry to let me know what numbers need to be symmetric. Okay? Questions? Okay, that's one way that we could do that. Okay, another way, we're going to look at the same equation, is we're going to try or look at finding the axis of symmetry. Okay? And to do that, we need to know a formula. That formula is x equals negative b over 2a. So in order to solve for this formula, I need to know what my a equals, what my b equals, and also what my c equals. Okay, so does anyone know what my a would be? What?
X?
A number. What would it equal? What's in front of the x? 1. So I have an imaginary 1 right here. So my a equals 1. So what would my b equal?
6.
Positive or negative?
Negative.
Negative 6. So my c would get equal what? 2. Okay, so when I go to solve this, what do I need to put in there? Well, I have x equals negative b over 2a. Do I have a c in there? No, so I don't need to use that right now.
You need to.
Substitute a and b. So what would this be up here?
Negative 6. There would be a positive.
It would be a positive 6 because this is a negative times b. And negative times negative 6 is positive 6. And then on the bottom I would have what? 2 times what? 1, which is, so I would have 6 divided by 2. So x would equal 3. What was x equals 3 when we graphed it? It was the axis of symmetry. Okay? So now we do have our x for our vertex. How could we find our y for our vertex? Yeah. Okay, so I could substitute the 3 in here or here? The top one. So we would substitute 3 into the equation. And that would give us our vertex. So if we substitute that in, we have 3 squared minus 6 times 3 plus 2. So first, if we don't have our graphing calculators and we can't put the whole equation in, what will we need to do first?
Quotations. I'm at parentheses, not quotations.
Exponent. So 3 squared is 9. 9 minus, what's 6 times 3?
Negative.
Minus 18 plus 2. Okay, so what would my vertex point be? I have an x and I have a y.
3 negative 7.
3 negative 7. Was it 3 negative 7?
Yes.
Yes. Questions? What? Are there any questions on how we got negative 7?
What's Where's the C at? Where's the C coming from?
The C, what did we say that the C represents?
Y-intercept.
The y-intercept. Okay, so when we go to graph this, what do I need? Why do I need that?
Oh, that's a starting
No,
point.
that's
a point.
What?
Add on to the sum of it.
Adds on what?
The sum.
I don't know.
Okay, so who said starting point? You and you. Okay, so we can draw our graph and we can go to 0, 2 and put a point. Okay, and now we know our vertex, so we know our lowest point, and we also know our axis of symmetry. So if we know a point to the left, our vertex, and the axis of symmetry, what can we do?
Just like make it symmetrical to the other side and like flip it over so on symmetry.
Right. So we can find the other side and finish the parabola.
Do you really have to have all these points, or can you really just have 3?
You can have 3. Okay, and that's why we're doing it this way. Instead of taking what?
Even on my math lab?
I think my math lab has several different ways to do it. So it just depends on what it asks you to do. Okay? Okay, so if we look at our equation again, we need to know if it's going to open up or down. Because yes, we have our axis of symmetry, we have our vertex, and we know our y-intercept, but we need to know if it's going, if we need to draw this way or that way. So what can I look at to determine that? Alex? Okay, where? My starting point is my C, or my y-intercept. A. So is my A positive or negative?
Positive.
Positive, so it's going to open up. Okay? And my y-intercept, we said is C equals 2. So what is my y-intercept? What is that point? 0, 2. Okay? So when I go to graph this, which we already graphed it once, but I'm going to show you graphing it using these points here. Okay, where did I say I wanted to start?
2.
0, 2. So I'm going to go 0 and up 2. What other thing did I know?
Your, the symmetry thing, the axis of symmetry.
Okay. What else? What other point did we know? The vertex, which is? So I'm going to go 3.
Down 7.
1, 2, 3. Okay. And then Hannah said that we know our axis of symmetry, which is what?
3.
X equals 3. So you don't have to draw this, but you can. Because all I have to do is, okay, here's this point. There's my axis of symmetry. So I have to go 1, 2, 3 to the left. So if I mirror that on the other side, I just go 1, 2, 3 to the right. And there's my point.
So what will it ask you to do?
What?
Like what will it ask you to do?
I'm not really sure. I haven't looked at them.
Like will you just like graph the whole?
Probably. You'll probably have to graph the different points. You'll have to find the vertex. I'm sure you'll probably have to find the axis of symmetry. Things like that. Okay. So once I have my third point, I can then draw my graph.
That looks like a street.
That looks like a smiley face. Oh, yeah.
Questions? Okay. So y equals negative 2x squared plus 8x. What am I missing here? My c. So if I don't have anything there, what does it mean?
Is it a 0?
Okay, so what would represent 0 though? Like what would 0 be? What?
Positive 1.
Okay, if I don't have a C, that means that the y-intercept
There's not 1. 0,
0,
0.
0.
Yeah.
Okay?
0, 0.
Good. Okay, so to find the axis of symmetry, what is my A?
Negative
-2. What's my B?
8.
8, and then my C is 0. Well, the C is just equal to 0. But when I go to do the y-intercept, it is equal to, or it is 0, 0, because it's a point. Okay, so to find my axis of symmetry, what do I need to put in for B? Alex?
8. Wait, negative 8.
Negative 8 over 2 times,
Negative 2.
so 2 times negative 2 is what?
Negative 4.
And then negative 8 divided by negative 4 is 2. So what do I need to do now that I found my axis of symmetry? I substitute it where? Okay, into the equation for x. So I would have y equals negative 2 times 2 squared plus 8 times 2. So what would my y equal?
8.
So I have negative 8 plus 16, y equals 8. So my vertex is what? 2, 8. So that's going to be what point on my parabola?
It's going to be a positive.
What?
It's kind of like positive, so it'll open down.
Open up.
Wait, you're opening, like,
Why will it open now?
The vertex is positive.
What do we look at to see if it opens up or down? The A. And the A is what?
Negative.
Negative, so it will open down. Got it?
Yeah.
Okay, so what does that mean about my vertex? Okay, but is it the highest point, okay? So now that I have my vertex, we just said that what about, is it going to open up or down? Down, and why? Because A is negative. Okay, and my y-intercept is? Okay. 0, 0. Because the C equals 0. So my y-intercept will be 0, 0. So if I go to graph this, where did I want to start? 0, 0. What other thing do I know that I can plot? 2, 8. Okay, and what is that? The vertex. What else do I know? X equals 2, which is the... Okay, so I can draw that line. Okay, so if I go from the axis of symmetry to this point, I go over how many? 2. So I need to go to this way. Questions? Okay, do this one by yourself, and I'll walk around. Okay, what does the A tell me? Yeah. Okay, if it's going to open up or if it's going to open down. What does the C tell me?
I think it shifts up or shifts down. We're starting.
Okay, the y-intercept, so where I can start my graph, okay, or my parabola. So how am I going to find the axis of symmetry? So x equals negative b over 2a. But before I can do this, what do I need to know? And a. So my a is 3. Okay, b is what, Alex? 12. And then my c is 4. So what numbers will I put in here? So I'm going to have a negative b over 2 times 3. 2 times 3 is what? So I have negative 12 divided by 6, which is negative 2. So my x equals 2. What do I need to do? Sean?
Put it back in that.
Okay, substitute back in for x. So I have 3 times negative 2 squared plus 12 times 2 plus 4. So y equals what? Negative 8. So what is my vertex?
Negative 2, negative 8.
Negative 2, negative 8. So that gives me, is it going to be the highest or lowest point? Lowest, because it's going to open up. And then what else do I need to know? What does the C tell me? The y-intercept, so 0, 4. Okay, so where do I want to start? At 4. Thomas. Okay, I can start at negative 2, 8. Okay, so I'm going to go to the left 2. Down 8. What's the other thing that I know?
Starting point, which is
0, 4. So what does that mean? Where am I going to go?
4.
So I'm going to go up 4. What do I need to do now? Is it done? Okay. So what is the axis of symmetry though? The axis of symmetry. X equals negative 2. So that will give me my line of symmetry. Okay? And where do I go from there?
You go over the line 2.
Okay? How do you know that?
Because it has to be equal on both sides.
Okay, so I went this way too. So all I have to do is go to the left. Okay? Questions? Okay, where do I get my y-intercept? From the C. How do I know if it's going to open this way or down? A is positive or negative? Any questions? Okay, homework on my math lab.